All right, so what we're going to be doing today and possibly tomorrow is we're going to be going over the 6 weeks test review. In this particular question, it says, what is the domain? Now, this is a very difficult graph to look at, so we're going to go and make this graph in our journal. So right now, if you would please, go ahead and make an x-axis right here. Make an x-axis. Make a y-axis in your graph. Now you're going to plot a point with me, which is the point's going to be at 3 and 4 right there. So that point is at a 3 and a 4. And then you're going to kind of just draw a parabola going up this way and this way. So it doesn't have to be a perfect looking parabola. That's okay. But we're going to call this parabola, we're going to call it h of x. So that's basically all you need to do. Make a little x-axis, make a little y-axis. We're going to make a nice little graph right here, and we're going to talk about two things. One of the two things is called the domain. The other thing we're going to call is the range. Now, quick little review. X always deals with your domain, y always deals with your range. Whatever you write in your journal, you are going to be allowed to use on the 6 weeks test. So if you take really good notes, they can be helpful to you. If you do not take good notes, they will not be very useful. Okay? So the domain is the set of all of your x values. The range is the set of all of your y values. Now this particular question said, what is the domain of the graph? So ask yourself, what x values are being plotted? They look like they're going forever to the left and forever to the right. So what could we say our domain is equal to? I heard somebody say something. All real numbers. All right, all real numbers is the domain. Now, if you wanted to write that in set builder notation, you would say the set of all x values such that x is an element of the real number system. Now I realize that looks a little complicated, but I'll make sure I go over it one more time. This means the set, those are the set symbols, of all x values. That line right there means such that x is an element. So funny looking E, that means element. And that capital R means the real number system. Now in interval notation, we would say it goes from negative infinity to positive infinity. All these mean the exact same thing. So that, they all mean the exact same thing. But as an Algebra 1 student, what am I typically going to put as a multiple choice? Just what? All real numbers. What would you see as a pre-calculus student? This. What would you see as an Algebra 2 student? That. So there's your Algebra 1, there's your Algebra 2, there's your pre-cal. What are you going to see in college? Which one do you think you're going to see in college? The top one. That'll be interval notation. That's what you'll see in college. There you go. All right. Now, the range is the set of all of your y values. Now, do the y values go up and down forever, or is there a starting point for your y values? Starting point. What is your starting point for your y values? Nope. Y-intercept's over here. Where? 4. Yeah, right there. So look, what's your y value start at? Your y value starts at a 4. Now, from there, is it getting bigger or smaller? Bigger. So you would say, listen, your range, you would say your y values are greater than or equal to the number 4. However, if the graph is called h of x, you have to write it this way. You'd say your h of x, remember this is function notation, is greater than or equal to the number 4. This is what you're going to see on your STAR test. Okay? You'll either see this or you'll see this. Now in interval notation, this is what you'd see. You'd see hard bracket 4, comma, infinity. Now what does hard bracket mean? Hard bracket means equal to. So it's either equal to a 4 and it goes on forever to infinity. But what do you guys need to know for your 6 weeks test? How is it going to be written? Either this way or this way. Let's take a look at what was on here. Now, this says what? What is the what? Domain. So what did we say the domain was, everybody? All real numbers, right there. All real numbers, okay? But if I scroll down just a little bit, it's like it's the same picture, right? But what does this say? What is the range? And we said the range was all values, what, greater than or equal to 4. So this was the answer for the range. So we did numbers 1 and 2 in our journal. They just look a little bit differently, right? They have the domain and we have the range labeled. Okay, let's go on to right here. Here's what I need you guys to do. All I want you to do in your journal right now is I need you guys to make this map. Make this map. I'm going to give you a whole minute to make a beautiful map. Label that x, label that h of x, label this the domain right here, label that the domain, label this the range. So please go ahead and do that right now. And it says what is the range, but we're also going to find the domain. So I'm going to put D for domain. I'm going to put R for range. I'm going to give you guys a minute just to get this taken care of right now. All right, guys, so here's what we're going to do. It says what is the range of h of x, okay? So right now, just build a little set right there. Build a little set, okay? So the range is just your y values. So what literally are my y values?
4, 14, 32.
That's it. 4, 14, 32. Those are my range. That's it. Now, if I said what was the domain, what would you guys say the domain is? Yeah. What's the domain?
7, 5, 3, 8.
Very good. So it would be these numbers right here. These are the domain, except I'm going to write them from what? Least to, so -4, a 3, a 5, and a 7. So it's not a very good bracket. But these brackets that I'm attempting to build, those are called set brackets. There we go. That's a better set bracket. Okay? So those are set brackets. So right here, what would the answer choice be for us that would be the correct answer for number 3? D. Now, what would be the answer for, what does A represent? The domain. So listen, if I gave you the exact same question, I put what is the domain of h of x, then you would choose A. If it says what's the range, you choose D. Now, when are we going to choose these guys? Whenever the graph looks what? Looks like a continuous graph, not just a graph of just ordered pairs. Okay? Oh, is this a continuous graph? Yes, it's continuous from here to here. Now that's kind of hard to see. So listen up. We're gonna go ahead and do our best to draw this one out. Okay? Here we go. Now it's going to be important that you make your x-axis way up high. And I'll make my y-axis way right here. So understand, my y-axis is right there. Here's my x-axis. I'm going to go over 1, 2, 3, 4, 5, 6, 7. I'm going to put a big old solid fat dot right there at a 7. I'm going to go over -1, -2. So right here at -2, I'm going to put a big old open circle. And then let me go back and take a look at it real quick. It looks like I'm at about a 2.5 and a -8. So about 2.5 and down 1, 2, 3, 4, 5, 6, 7, 8. Right there. Put a big old fat dot right there at a negative, not -2, a positive 2.5, comma -8. Now the best way I can do this, it's probably not going to be perfect, is I'm going to try to connect our graph going that way, going down. This is harder than it looks. That's not bad. Okay, that's not bad. So there's your graph. Make sure that's open. Make sure that's closed. We are going to talk about two things. We're going to talk about the domain, and we're going to talk about the range. Just remember, D stands for domain, R stands for range. We're going to put MIN, and we're going to put MAX for both of them. What is MIN short for? Anybody know? Yeah, minimum. What is MAX short for? Maximum. So think of it, smallest, biggest, smallest, biggest. Okay, so kind of get it all set up. Just remember, guys, domain deals with your x values, range deals with your y values. Okay, so let's look at the domain here. What's the smallest the x values get? Correct, right there, at a what? -2, so put -2. How big do the x values get? What's as far as they go? 7. Now, would you guys agree? The maximum has a solid dot, but the minimum has an open dot, right? Maximum solid, minimum. Now, does anybody remember what the solid means versus the open? All right, so how about this? For open, just put not equal, right? So we know it's going to be what? Not equal. And for the closed in, that's going to be equal. So it's like it's equal to, it includes it. So we're going to say all the x values are less than or equal to a 7, but they're just greater than a -2. And that's your answer right there. That's your answer for the x values. X is less than or equal to 7, and x is greater than -2. All right. So the range deals with our y values. What's this? Ooh, this is kind of tough. What's as high as this graph gets? What's the highest point that the graph reaches on the y-axis? Nope. It would be infinite if this was like an arrow going up and this was an arrow going up forever. But it stops. Yeah, it stops right here at what? 0. But wait a second. I thought it's not including 0 here because it's open. You're right. It's not including 0 here, but is it including 0 right there? Yes, so therefore we have to put less than or equal to 0 because this is a solid dot right over here. But what's as low? What's the lowest point that it reaches? Where? -8. So it gets all the way down to what? -8, and it has a solid dot right there because it passes through it. So all of my y values are greater than or equal. My y values are greater than or equal to -8. And that's your answer. That would be the answer for the domain. This is the answer for the range. Now, if I labeled this, let's say right now, I labeled this graph. I call this graph g of x. If I called this g of x, what could I replace the y value with? I could replace it with g of x because that's function notation. Okay, so I could say g of x is less than or equal to 0 or greater than or equal to -8. Just understand, sometimes it'll say y, sometimes it'll say g of x or f of x or h of x. That's just function notation. No need to get freaked out. Okay? So on this one, what's the domain, everybody? The domain was between what? 7 and -2. So this answer was D right here. That would have been answer choice D. Oh, range. I'm not going to make you guys draw this, okay? I'm not going to make you guys draw this. However, could you please pay attention? This says what? What is the range? Range goes from the smallest up to the biggest. So if you wanted to watch this video later, you could see it. How low does it go? How high does it fly? So we all the y values are between a 2 and a -7. What would you guys say the answer is? Between a what? -7 and all the way up to a what? 2. A. That's number 5. I'm not making you draw that. That was just the answer to number 5. Oh boy, here we go. This is where you guys need some help. Trust me. I saw some answers. This is where you guys need some help. So check this out. Put a x minus 5 equals b. And I need you guys in your journals, title it solve for a specific variable, not the Pacific Ocean, a specific variable. So solve for a specific variable. I want you guys to write solve for a. I'm going to highlight the a because that's what we're solving for. You have to pay very close attention to what you're solving for. Otherwise, you won't be able to solve for the right one. All right, now listen. If I wanted to make this easy, I could say solve for b. What would you guys say b is equal to? Anybody know what b is equal to? No? Oh yeah, okay, yeah. And y equals mx plus b, b is equal to the y-intercept. What? Yeah, if I said solve for b, then the answer would be this. That'd be done. Because that's what b is equal to. But what does it say? It says solve for a. So what do we have to do? We got to get all the a's by themselves. So by the way, this a times x is under a negative influence, and I got to get rid of that negative influence. How do I get rid of a -5? Then do it. Add a 5 and add a 5. Now, this is the part as an algebra teacher that we're hoping the students know. What can they combine and what can they not combine? So,
Variables go to the variables, numbers go to the numbers,
Right. So can I add these together? No. So since I can't combine them, I have to leave it as b plus 5. I have to leave it. Once again, remind yourself, what are we solving for? We're solving for a. So I have to divide both sides by a particular variable to be able to solve for a. Does anybody know what variable I would have to divide both sides by? I heard it. X. X divided by x. They cancel out to a 1. Your final answer is the sum of b and 5, all divided by x. This is your answer. We're not going to do just one of these. We're going to do all of the solving for a specific variable. It follows the same pattern. Okay? So right here, what would you guys choose for this particular answer? What answer would you guys, hopefully you guys see the answer. There it is, right there. Okay, guys, what does number 7 say? All right, let's solve for W. We're not going to retitle this. This is under the same. Solving for a specific variable. 6W minus Y equals 2 times Z. I'll give you a chance to write it down. I'm going to highlight the letter that we're solving for right there. That's what we're solving for. So write it down. And we're going to solve for that specific letter. So we're solving for W. All right, so I have 5 brave students that have volunteered to help me solve this problem. So here we go. We're solving for what letter? Very good. So far, so good. Okay, so I got to get all the W's by themselves. Anybody want to volunteer what you think I'm going to do to both sides? Go ahead. No, thank you for playing. Yes. Yes, very good. Now, I'm not using students' names because this is being recorded and be putting on YouTube, okay? But yes, one student said add y to both sides. Now, notice we cannot combine 2z and a y, so we have to leave it. 2z plus y. All right, so this zeroes out. Does anybody want to raise their hand to let me know what I have on the left-hand side? Yes, sir.
6W left.
Very good. 6w left, but 6w equals, and I'm just going to bring down 2 times z plus y. Do I have any volunteers of what I would do next? Go ahead, sir.
You subtract.
No.
I mean, you divide.
Yes.
2t plus y by 6.
On both, we have to divide both sides by 6. Very good. So these will cancel out. So here's your final answer, everybody. W equals 2 times z plus y all over 6. That would be the answer. Now, if I wanted to confuse students and make sure that they really had to know stuff, here's what you'd have to do. Ready? I'm going to put or. You guys ready? Or W could equal, does anybody know what 2/6 reduces to? Right, which is a fraction of 1/3. All right, so if I wanted to, I could put z over 3 plus y over 6. This is also an equivalent. These are equivalent expressions. Okay, so how the heck did I get z over 3? Because 2 goes into 6 how many times? 3. And then y over 6 just stays y over 6. These mean the same thing. All right. Moving on. Ooh, very good. Okay, everybody. This is going to be super important here. I want you guys right now to write ax plus by equals c. And I want you guys to write y equals mx plus b. Everybody, this is what's called standard form. This is called slope intercept form. Okay, the whole purpose of being able to solve for a specific variable, all right, is to make sure you guys know how to change standard form to slope intercept form. Does everybody see how this is in standard form right here? Ax plus by equals c. So right now, what I'd like you to do is put 6x minus 3y equals 12. And when it says solve for y, what does that mean? It basically means you're changing it to slope-intercept form. So right now, I'm going to give you guys a whole whopping 1 minute to see if you can solve this on your own, and I will check it after a minute. For those of you who are watching the video, I'm pausing. All right, as I solve this, just remember, the numbers are going to change, but the process is going to remain the same. So if you were a student and you were attempting to solve for the letter y, which is right here, the very first step that I would do is I would take away a 6x from this side, which zeroes it out. And I would take away a 6x from this side, but I cannot combine these. Now, being that I can't combine these, and I want to get it to y equals mx plus b, watch what I do here. I'm going to bring down the negative 3y. I'm going to set it equal. Now watch what happens. I'm going to take the x's, I'm going to move them all up front and put a negative 6x up front. And what number am I just going to put in the back right here? I'm going to put the positive 12. Wait a second. It doesn't say positive 12. Well, if you don't see a negative in front of it, it means it's positive. Okay? Now, this is what I noticed a lot of students do, and they did it exactly right. They divided everything by a particular number known as negative 3. So I divide everything by negative 3. Now, just remember, a negative divided by a negative changes it to a, yeah. So these cancel out. So we get y. Now, y equals. Remember, what did I say I want to get? I want to get y equals. Now, negative 6 divided by negative 3 is a positive 2. And then you stick x next to it. And 12 divided by negative 3 is negative 4. And you're done. What would my, by the way, what would my slope be or my y-intercept be in this particular question? Yep. Which would be a what? What kind of slope? A 2 over a 1 slope. And what's my y-intercept? Negative 4. Okay? So that would be my y-intercept. Remember, in a slope, you go up 2 units and over 1 unit. Okay? Now, let me tell you guys an equivalent expression that was true that would still be considered a correct answer. You just didn't finish it. Ready? Some people had this answer. Ready? They had 12 minus 6x all over a negative 3. Okay? They had that. Guess what? Are these the same? Let's check. Let's just check. Ready? I had what? Y equals 2x minus 4, right? And I had y equals, and then there was a division, and what did we put? 12 minus 6x over negative 3. Are these the same line? They're the same line, but what's the difference between these two lines? This is considered slope-intercept form. Is this in slope-intercept form yet? No. So what do I want students to be able to do? Here's the whole point of this video. The whole point of this video is to make sure that I teach students how to go from this to this. What is 12 divided by negative 3? What's 12 divided by negative 3? Negative 4. What's negative 6 divided by negative 3? Positive 2x. So I had one student that wrote this, which is really, 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 really close. What was the only thing she had to do? Was just what? Reverse it. And now it's in what form? Slope-intercept form. What's the slope? It went up 2 over 1, up 2 over 1, up 2 over 1. What's the y-intercept right there at a negative 4? In this day and age, it is easier for you guys to learn than it was in my age. You guys have more technology, more YouTube videos, more people teaching you how to do stuff than I ever had at my age. You know what I had to do to learn stuff? I had to go to the library. I had to read textbooks. I had to ask teachers and hope that they didn't, make me feel ridiculous. All right? So, make sure you're paying attention and learning. Oh, here we go, guys. Here's an easy question. You guys ready? This one says what? What is f of negative 2? Can you guys please put this in your journal and this in your journal. That's it. Just those two things right there. That's all I want you to put in your journal right there. I'm going to go ahead and pause it. Now, when you write this down, I'm going to write this down with you real quick. We'll put f of x equals parentheses x minus 3 close parentheses squared plus 4. And then I'm going to say, what is f of negative 2? Now, hopefully, if I write it this way, it'll help it make sense. If f of x is equal to x minus 3 in parentheses squared plus 4, what is f of negative 2? Well, literally, what's the only thing I have to do in this particular problem? Wherever I see an x, what am I going to plug in its place? That's it. Just replace it with a negative 2. Does everybody see that's all I did? Now, if you have a calculator, you know what you could do in the calculator? If you have a calculator, you could plug that in exactly as it appears, press enter, and you will get the right answer. Okay? But do parentheses matter when you do it? Yes, you better. So here we go. Negative 2 minus 3 is negative 5. A negative times a negative is a positive. So negative 5 times negative 5 is 25, and 25 plus 4 is 29. So the answer to this particular question, what did you have to type in? You had to type in a 29, and that would have been the correct answer. This is called, by the way, does anybody know what type of notation f of negative 2 is called? It's a very fun type of notation. Yes, function notation. So that's called function notation. Okay? All right. Here's our last problem. Right here, guys. Last thing we're going to do is I need you guys to put this right here. Put that in your journal. All right? So what we're going to do, as you're writing it down, here's what I'm going to do. I'm going to find out what f of 0 is. I'm going to find out what f of negative 7 is. I'm going to find out what f of 5 is. And I'm going to find out what f of negative 2 is. Just remember, if I say what is f of x, I'm literally looking at when the x value is 0, negative 7, 5, negative 2. I am looking for what is the corresponding y values for these x values. That's all I'm doing. So if you make this map right here, this is called a map. Remember, these are your x's, these are your y's. Once again, this is your domain, and this is your range. Okay? So here we go. If I plug in a 0, if that's my input, what's my output? If I plug in a 0, what's my output? Negative 1. Boom, done. If I plug in a negative 7, what's my output? Same thing. If I plug in a 5, what's my output? Negative 9. If I plug in a negative 2, what's my output? Negative 4. So what was the answer? What is f of 0? What should you have typed in? Negative 1, and that was the answer. Okay? What do I want you guys to understand how to do? How to interpret what? Function notation. What does this represent? That represents your input. And for when this is the input, you're looking for your output. So these are all your inputs, and you're looking for your outputs. That's it. We will finish going over this review tomorrow.